Okay, we'll get started. In this section we're going to be looking at 2G, which is going to be scalars and vectors, and what are the differences between the two. So the first thing is to realize that all quantities are going to have a magnitude, or size, and that magnitude really is saying how big or small something is. So for example, 4 meters, the 4 is saying how big that thing is. 5 meters a second, the 5 is saying how fast that thing's moving. $3.21, that number is telling you how much money you have. So all things we look at in physics are going to have size. But only some quantities are going to have a direction as well. So all things we look at are going to have a magnitude or size. Not everything is going to have a direction. Only some things will have a direction as well. So we split all the quantities we're going to look at into two groups. So the first group that they're split into are scalars. Scalars. And those are quantities that have a magnitude only. So for example, mass. Like for a mass, you have 5 kilograms. And that's just a size. There's no direction associated with 5 kilograms. It's just 5 kilograms. It's not 5 kilograms left or up or to the west. So this would be a scalar. The next quantity, right, another example of a scalar would be distance. It's just how far you've gone. It's not how far and what direction. Length is just how long something is. Speed is just how fast you're going. It doesn't include a direction as well. So all of these are scalars. Now the opposite kind of to that, not opposite, but the other type of quantity we can have is vectors. Vectors. So those are quantities that have magnitude and direction. For example, displacement, right? Because displacement could be positive, negative, it could be north, it could be south. Position could be positive, negative, it could be in different directions. Velocity could be in different directions, up, down, north, south, east, west. Acceleration could as well. And remember, that's important for determining if an object is speeding up or slowing down, because its direction determines that, really. So those are all. So the next thing would be to look at what are some examples of vectors. How might you see them? So these are some examples. So 5 meters a second, or negative 5 meters a second, the negative is the direction, the 5 is the magnitude. 8 meters a second squared, west would be the direction, 8 would be the magnitude, and 2 meters a second forward. 2 would be the magnitude, and forward would be the direction. So again, all of those are vectors because they have size and a direction. And the last thing here is to remember that vectors, they can be represented by arrows. So if you want to draw a vector, you can draw them as an arrow, usually with the quantity labeled above it. Like acceleration would be an A labeled above that arrow. Right, in this picture there are two vectors. There's a velocity vector going one way to the left. Then there is an acceleration vector going the other way to the right. So velocity, acceleration, and this object would technically be slowing down because they're not agreeing. So that's really it with scalars and vectors. Just remembering what's the difference between the two, and what are some examples of quantities that are one or the other, and then realizing that we can represent vectors by arrows. Technically you can represent scalars as just like a dot. Like if you did like this, a dot and then A, that would indicate that the quantity is 0. So like this is like 0 acceleration. So technically you could draw scalars too. They're not as common. So that's all the information. Now we're going to see a problem with this. So before I go through it, make sure you solve it out first. And I will go through and explain it in about a minute. So again, make sure you're solving it first. Okay, we'll go through it. So identify if the following are scalars or vectors. So these 5, all of these are either scalars or vectors. The first one, I'm just going to write S or V. First one's well, I'll actually write it out. The first one's scalar because the amount of money in your bank account is an amount. It's like, I don't know, $500. It's not $500 west or east. It's just an amount. So it's a scalar. This right here, this is a velocity, 10 meters a second south. It tells you how fast it's going and in what direction, so this is a vector. Speed is always a scalar because it just says how fast something is going. It doesn't tell you which direction. It just says you're going this fast. You're going 3 meters a second. The next one, number of people in New Jersey, that's a scalar because it's just a number of people. It's just like, I don't know, there's 500,000 people. And again, this doesn't have a direction associated with it. It's just a number. It's just a size. And the last one, velocity. Well, it's important to remember that velocity is made up of speed and direction, so it has both. So velocity definitely is a vector. It says how fast you're going and in what direction. So that's about it for this problem. Again, not a more straightforward section, but make sure you have the notes, make sure you have the solution copied down, and that's it for now.